Okay, so we're going to take a look at computing standard deviation from a set of sample data. So we've got 5 data values here that are taken from, it's a sample taken from some population. You can think of something creative that they might represent. Before we can calculate the standard deviation, we're going to need the mean. So to find the mean, we're going to go ahead and find the sum of all of the values divided by the number of values. And if we real quick go across there and add those up, I think the sum is 22, and there are 5 of them. So in this case, the mean is going to be 22 divided by 5, which is 4.4. So we found our mean, 4.4. To find the standard deviation, we're going to use our formula for standard deviation. The formula for standard deviation is we're going to take the sum, and again that sigma symbol means sum, of the differences between each of our data values and the mean. So we're going to take each data value, we're going to take the 2, we're going to subtract 4.4 from it, the 3, subtract 4.4 from it, and so forth. Go across the data values and do that for each one of them. And then we're going to square that. The reason we're going to square that is because that's going to eliminate any signs, any negative signs or positive signs. That way when we add them up, we'll get the sum of the squared deviations. If we didn't square them, then they would tend to add to 0. This way we can actually find the sum of all the deviations from the mean. And then we're going to divide by n minus 1. We'll get into why it's n minus 1 later on, but for a sample, we'll divide by n minus 1. If we actually had every data value in the population, then we would actually divide by n instead of n minus 1. And again, n is the number of data values. And then right now, what I have, this formula I have written right now is actually the variance, which is the square of the standard deviation. So our last step, and I didn't leave a whole lot of room for it, is going to be to come back and take the square root of all of that. So in order to do this, I find it's often helpful to actually make a bit of a table. So I'm going to make a table. I'm going to have the first column is going to be my x minus x bars. So the first x value, the first data value we have is 2. We're going to do 2 minus 4.4. We're going to do 3 minus 4.4. We're going to do 5 minus 4.4 twice. So 2 minus 4.4 is negative 2.4. 3 minus 4.4 is negative 1.4. 5 minus 4.4 is 0.6. 5 minus 4.4 again is 0.6. 7 minus 4.4 is going to be 2.6. Now, this column is going to actually end up being our x minus x bar squared. So we're going to go ahead and square each one of these values. And this is the step that's going to eliminate all those negative values, because when we square the negatives they'll become positive, and we'll actually be able to add up the distances that each value is from the mean. And this guy ends up being 5.76 negative 1.4 squared is 1.96. 0.6 squared is 0.36, and of course still 0.36, and finally 2.6 squared is 6.76. So at this point we have taken care of the x minus x bar, and we've squared it. The next move is to divide by n minus 1. So actually, I'm sorry, the next move is to take the sum and then to divide by n minus 1. So what I'm going to do is I'm just going to put a little bar underneath here. I'm going to go ahead and add those values together. Give me a second. And we've got 15.2 for our sum of squared deviations. So there's our sum. So now our variance, so the sample variance is equal to 15.2, 15.2 divided by n minus 1. We have 5 data values. 5 minus 1 is 4. So if I go ahead and divide those two, I've got 3.8 for my variance, which is simply the standard deviation squared. And then finally, the standard deviation is going to be the square root of that, 3.8. And that is about 1.95. And again, the standard deviation represents the, to kind of oversimplify things, the average deviation from the mean. So typical value is, the mean in this case is 4.4, and the typical deviation from the mean is about 1.95. Okay, so hopefully that helps out. You can also, if you want to speed this up, you can go through this process in an Excel worksheet. You can use the columns that we just created in Excel, and I'll show you later on how we can actually calculate these things in Excel and also in Desmos.